Why, Frank, do kids say the strangest things about science?
Because they make it up. And we make it up. And they make it up. And, you know.
So that means there could be misconceptions.
Yeah, I think so.
All right, and that's what we're going to talk about. And as we talk to you, do you have a clicker or do you?
I have a clicker. Can you clicker? You clicker. Give me the word and I'll click it. See, I'm going to get back in these people's faces because they like to hide in the back of the room.
I know the word.
Yeah. Since I can emote and express all the way across the room, I'll be back here just to pick on you guys who like to hide from us, okay? Just because you guys know that the kids that sit in the back of the room are the troublemakers, we don't let the troublemakers get away with it. Oh, you know what, Dan? It's not going to work unless we plug it in the USB thing. You see that thing here? That needs to be plugged in. Jill!
Anyway, as we've worked with teachers across the country, one of the things that we've discovered is that, and also with college level students, pre-service students, we've learned that this is an area that hasn't been unrepresented in terms of the information that's provided, and it's really is very important. And there we go. Let's start out. Let me hear some feedback from you.
He wants to say something.
Yes, sir. What is a misconception as you would define it? What's your name?
It is something that maybe somebody has told you that may not necessarily be true, if you believe it's fact anyway.
Can you think of an example from your collection of misconceptions, maybe?
Maybe it has a face on it.
I can answer that!
Misconception. How else could you define it in terms of, all right, that's good. That's good. As it relates to your kids and school. Now that's certainly something that you can think of. I hear mumblings of words. Yes, sir.
Did you want the misconception or the definition?
The definition first.
I like this definition. Facts that, ideas or concepts that you have that you believe are true, which are not true.
Could part of a misconception be true, maybe?
Yes.
Oh, yeah.
Yeah. So it could be. Let's take a look and see what the so-called experts say. We did a little bit of information in terms of what the definition might be. Misunderstanding something, inaccurate information based upon faulty thinking. Now you teach school. Would you say that some of your students sometimes have those kinds of preconceptions as it relates to whatever topic you're working with? How many math teachers do we have in here? Oh, interesting. Science middle school. Okay. Science, and that could be a variety of topics, high school. It's kind of an even mix.
So are we just all math and science teachers?
Yeah.
Oh, cool.
Which makes it a lot
That means I
easier.
can really geek out this afternoon.
Yes, you
Ooh,
can.
boy, I just upped the content level.
All right, so what do we do? Students have misconceptions. You need to help your students get rid of them. So how do you do that? Hopefully you didn't hear that. Well, one of the things that you have an advantage of, you have a tremendous advantage of, is that you know your students. As the year progresses on, you know who they are, what kinds of things and how they respond, and that certainly is a strength that you have. And, well,
I think this gentleman here in the purple shirt, because it's so exciting, would love to say something on that.
yes, sir.
Well, students come to the classroom with their preconceived ideas from stuff that their parents told them or something like that, or their friends told them. And I think the only way that we can get rid of these misconceptions is to find out what misconceptions they have in the first place.
That's the challenge, isn't it? And that's something we need to think about as we kind of go through this part of the workshop. How can we do this? Well, we can understand our students. One of the keys to learning are misconceptions. And as I said, when we work with pre-service students, and we mention misconceptions, guess what? Not too many folks really mention this. We don't have a misconceptions one-on-one class as such.
You mean
Yeah.
pre-service teachers? You said pre-service teachers.
Well,
The pre-service teachers we work with at, say, Stevenson.
Yeah.
This was, they never even.
never
thought
heard
about
of it.
this.
Yeah,
So as they're learning to become teachers, they aren't being presented with this material.
exactly, and that is interesting, isn't it? So, why do we care about these student misconceptions?
Because it.
Yes, sir.
If you don't
We
correct
actually,
them,
it's
they're
going
gonna,
volunteer.
they're gonna perpetuate, they're never gonna disappear if you don't stop them.
Okay, you're nodding, so you got
They
it.
formulate
And
their
what?
thinking.
Say that again.
They formulate their thinking.
It formulates their thinking, and it's interesting how misconceptions can, they just stay there. What do you want to say?
I was just gonna add to that, one of the biggest misconceptions that, and actually we have to deal with this building-wide, this year is, with kids being taught the order of operations, and them being taught the please excuse my dear Aunt Sally, and kids not knowing that the multiplying and dividing go together and the addition and subtraction go together. And we were getting sixth graders, fifth and sixth graders that were coming in saying, no, this is how I was taught. And indeed, that was the case. Our teachers had a misconception.
Oh, is that possible? Teachers can have misconceptions? Let me ask the college people, is that possible?
Very possible.
Very possible, yes.
And
So-
and they had, the kicker was they had just been trained on it, and the person that trained them, so it was they had pulled out their papers, and it was the whole primary grade had been so they had taught it wrong.
Yes, sir.
Some misconceptions are not easily resolved.
You hear that? That's.
Say that loud.
Say that again, that's really an important point.
Some misconceptions are not easily resolved. When you go to the field of biology,
Mm-hmm.
when you get into evolution,
Ooh.
your misconception may be, to you it's true, but to me it's false, and vice versa. And you do get into some areas where you're not going to get resolution on that because of, I don't know, religious or political.
How many have encountered that particular world of the political and, okay, well, that's, obviously that can be a problem, no question about it. So they can stand in the way of new learning. You need to be aware of this and try to figure out ways to help students. Now, this is the fun part. We are going to ask you, working with your partner, as you can see, to brainstorm a list of examples of some possible student misconceptions about, not biology, thank goodness. That could be an interesting one. But the solar system. We already have learned a little bit about Saturn. But I bet you, how many of you teach anything about the solar system? Okay, that's good. And you math people, I'm sure you can probably come up with some interesting ideas or something from your experience. And then list, that's the first part. And then list where you think these misconceptions come from. We kind of talked a little bit about that, all right? Mitch, Brandon, you need to give out over here, student misconceptions. Start thinking about it. And on your paper, be sure you put your name and write down what you have. Paper's coming in. One set here.
Is it one per group?
No, it's one per person. Can you hand those to us?
Everybody gets it.
You don't want
The store still selling something that
Does everyone have a paper?
All right, if you have a recorder, and I suspect that's what you're gonna do.
Yeah.
Okay, that, which makes sense. Put down your name and put down the name of your partner so that we know who is working together on this, rather than having to duplicate ourselves, okay?
They don't get styrofoam balls. They're all made of styrofoam. Huge misconceptions about this. I'm making them on the floor. Down the hallway. You go way down low. You can scale. Not real low, not real How's it going, Dave? Side on the other side of the wall. That's not the same.
So I was at,
Yeah, we're doing part A and part B.
I know this is one thing that a lot of people right here and see why there's no error. That's why is why and I said, I don't know. It'd probably be better if it stayed flat. It was fabricated. Wait. But my opinion is, why not, so they don't have like their just the normal rest. Don't have
All right, let's talk. A list of examples of some possible student misconceptions about the solar system. Okay, listen carefully. Let's see how many we can come up with that you've heard, or maybe you just know about.
First one I have, students believe space has sound in it because of the vacuum. It has to have sound because of the vacuum.
Because, and I gotta go to B. Where do you think that baby came from?
No, that's the definition of what a vacuum is.
Oh, vacuum.
It took forever, but the students were thinking that vacuum was a vacuum cleaner.
Absolutely, yes.
Yeah, I mean,
And a vacuum cleaner makes lots of noise.
Right.
So that vacuum cleaner out of space must be making lots of
Did you hear
noise.
what he said? I hope you didn't hear that.
I heard it.
Yeah, that's true.
Well, no. We actually use that as for black holes. Because, well, we'll save that one because that's another misconception you might have, but it's not the solar system.
Okay.
Okay, so misconception of the word vacuum leads to a somewhat unrelated, somewhat quizzical misconception. Okay, next.
Yes, sir.
That there's no variation in where and when the sun rises and sets.
The sun rises in the east and sets in the west, right? And it always rises in the east, it always sets in the west.
Directly above you.
Yep, and at midday it's right above you, of course.
Misconception.
Okay?
Yes, sir.
The Earth is closer to the sun in the summer and farther from the sun in the winter.
Bingo!
That's a classic.
That is an incredibly classic one because it makes so much sense, right?
Yeah.
Except if you're in Australia. Because their summer is opposite of our summer.
That's right.
And that's how, and you have to confront them with that and go, and let them puzzle on it. Okay? Because if you don't let them puzzle on it, and you just, in giving them an answer, you have to let them just think about it. Okay?
This gentleman had one up here.
Moon lights up.
You mean it does?
Yeah.
Yes, sir.
That the moon simply orbits only the Earth, and the Earth is not affected by the moon as long as it has a wobble. Basically stationary.
Okay.
Cool.
Planets have circular orbits.
Okay. Over here.
Well, the moon was only out at night.
You only see the moon at night. Yes. Because it's never shown during the day in a movie or a TV show, right?
Yep.
The moon is always up at night, right? Any night you go out, you can see the moon, right?
Yes. Yes, ma'am.
There's no gravity in space.
Oh, yes.
You like that one, right? Yep, that's a good one.
The globe is always has to have the North Pole on top.
You hear that?
I didn't hear that. Sorry.
Again.
A globe of the Earth must always have the North Pole on top.
Excellent. Idea is that there is an up in space. All right? That the idea that what we consider the North Pole is arbitrary. Do you know that our north geographic pole is what pole in the magnetic sense? It's our south magnetic pole. Okay?
Any others? Yes, sir.
The astronomers know what they're doing to just make Pluto disappear.
This is
For my next trick, we shall take a planet and make it disappear.
This is a very sensitive topic, as you will find out
It's
later
not a
in the day.
sensitive topic.
Well, for you.
Only for you.
No, I know, but with Pluto, you'll find out about Pluto and Frank later on today. Okay. Anything else? Yes, sir.
The cameraman.
What causes the moon phases? There's a lot of misconception about what mechanism is that.
Well, there's a lot of confusion about that one, that's for sure.
Phases of the moon.
It's interesting how much moon we've got now.
Got a lot of them,
Yeah,
yeah.
a lot of moon things.
Okay.
Yes,
Only
sir.
Saturn has rings.
Yes.
Okay, so we move on to B.
Yes, go to me.
Where do you think these come from? Yes.
I think you said earlier that the media things that kids see in TV and movies.
Okay. Can you give an example of one?
Star Trek.
Star Trek. Okay. All right. Can anybody think of a misconception that might have come from a Star Trek film? Back in space. Everybody who grew up and saw Star Wars knows that you can hear laser beams shooting across space, right? All right? Right? The TIE fighters and everything. You know you can hear that across space because you saw it in Star Wars. Oh, when you swing light, yes, it makes noise. I take my flashlight and I go vroom, vroom, all the time. It's a lot of fun.
Anyone else as it relates to B?
You make them up.
You mean people make up misconceptions, you think?
Can we go that one? Can we go a little further with that one? All right. Why do you think they would make it up? Okay. Makes common sense to them. All right.
Things that they've heard from their family or parents.
Okay, but actually, the making up is a really important one to recognize. Why do they make up misconceptions? They don't know the answer.
But it fits with their experience.
It fits with their experience.
Fits with their observations. We're warmer in the summer. Well, we are warmer in the summer.
Like heavy light.
Fits with their observations, okay? And to me, the main thing is they are intrinsically curious. They intrinsically want to know why something happens, and if they don't have a good answer, they will make up their own.
We humans are good at that, aren't we?
Oh, we're really good. Okay? Don't get me started on that.
All right, I'll tell you what, Frank.
She had something to say.
That they have misconceptions from their parents or relatives. They heard something and they believe it must be true because mom said it.
Uncle Bob tells you all sorts of cool things, right?
All right, let's go on. Let's talk
Okay, go ahead, go
about
ahead.
All right. So, comments about the solar system, where do you think we, am I going the right way? Yes. Frank, you've got to talk about this one. This brings up a lot. Textbooks. How many of you have textbooks? All right, let's talk about it, Frank.
There's the number one problem you will have with your textbooks, and we call it the 3-inch problem. Okay? Every planet is printed 3 inches wide. Okay? And you, of course, don't get any scale for what the real size of the objects are. Now, the one good thing I will say about this diagram you see here is that they actually do an attempt to give you the relative sizes of the objects. It's not exact, it's not scientifically accurate, but it's reasonable enough that I can plot at that. Okay? What is a major misconception that this promulgates? That the planets are in a straight line. Okay. All right, there has been 4.5 billion years in the solar system. And if you do the multiplication of all the periodicities of all the orbits, do you know how many times in the entire history of the solar system they have been lined up like that? Exactly 0 times, okay? The periodicity that it takes to get them lined up is many, 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 many times the age of the solar system, okay? So they do not line up. All of these grand alignment, the grand conjunction bullshit you hear, okay? Call a spade, it's never aligned, okay?
Hopefully we're not recorded.
I am being recorded, okay?
Oh, yes.
I will say yes next time, sorry.
Textbook pictures as well, because they use the other like small images. I think due to the appearance that the asteroid belt like really close together and that the rings of Saturn are dense.
Exactly.
So what did you say you might want to read?
She said that like the asteroid belt is really compact, okay, and that the rings of Saturn are really dense, okay. What do you have to say about the rings of Saturn in terms of particle density?
They are not dense.
Can you fly a spaceship through them
Yes, very easily.
and not smash into something?
Yeah, you would, yeah.
How is that possible?
It would be very easy to pass through and not worry about.
Have we actually done that?
Yes.
Several times. We have flown a spaceship through them.
It's like even from these images or the public
Yeah.
images, it's, you know, not just moving.
Because somebody mentioned that, you know, the rings of Saturn look like they're solid, right? And even if you know the particles, you say, wow, they must be really densely packed in order to get that, right? Okay, what's another misconception in this image that really bothers me? The spacing between the planets, okay? Is this doing any justice to the real spacing? Absolutely not. If you see a picture like this in your textbook, you have my permission to take a big red marker and put an X on it, okay? All right? And have all your kids do that. Just so they recognize the misconceptions they're being thrown at. Let's go on. Okay, so.
This is a great one.
We work for the Hubble Space Telescope. On the left-hand side, we have an artist's conception of Hubble in orbit. And on the right-hand side, we have a photograph from the space shuttle of Hubble in orbit. One is wrong, one is right. Why is the wrong one wrong?
Based on that image, the telescope is way too far away from the surface of the Earth.
Okay, can I have the pointer, laser pointer? Yes, that is way too far away from the surface of the Earth. And how can you tell that? Look at the curvature of the Earth. Look at the curvature of the Earth. And you can see that the Earth would be oh yay big, right?
Yeah.
Now fill out this in your brain and see how high Hubble isn't above the Earth, okay? You fill out that incredibly big Earth, and you realize that Hubble is really, 1/64th. I'm sorry, about 600, but 1/10 of an Earth radius away from the edge of the Earth, okay? It's really far away, okay? So if the radius is 10, this is 11 up, okay? And so the photograph can give you that real perspective. Now, I happen to know the guy who did this, okay? He was just putting it together real quick just so he could move it on and get on to this next project, all right? He didn't have a scientist geek like me looking over his shoulder saying, no, you can't do that. That's just not good. But this is all over the internet now, okay?
So that's a good reason why educators and scientists need to be
Why
working
Dan and
together.
I always go together.
All right, what's next? Student misconceptions. There's the good news as it relates to the solar system and space. But there is the real news. I always think of myself in the grocery store. I made some interesting classic. And of course, media representation. You might want to say something about each one of these in terms of what is in these movies, I thought.
Every single movie you see here has Hubble images, invokes the Hubble telescope. Okay, Armageddon, the president says, get that Hubble moving! I wanted to take pictures of an asteroid that's moving way across the street. And then, what's his name? Pulls out camera negative film as if it just came from Hubble and says, like x-rays, right? Negative film and showing this is what Hubble just saw, The Galaxy Quest just uses some Hubble images as background. It's a silly movie. It's supposed to be silly. I can't fault misconceptions there. Trekkies actually, there's one movie up here that does a good representation. It actually interviews people who work at the Space Telescope Science Institute and tell how Star Trek inspired them to get work in space. I don't remember the Naked Gun using Hubble, but I know there was something very silly about Mars Attacks. And Mars Attacks, of course, has pictures of the Martians from Hubble. Of course, Hubble doesn't focus, it doesn't follow spaceships going around and all that sort of stuff. There is this somehow a conception in Hollywood that the president has a red phone that he can call up Hubble and say, I want Hubble to take a picture of this. Okay. In reality, it takes 11 days to schedule Hubble. You want something immediately, you're going to get it 11 days later. Okay. That's our plan. I mean, there's a way we could possibly do, but Hubble slews across the sky incredibly slowly. It can't follow fast-moving objects. Okay, it just, there's all sorts of small things, the technical inaccuracies, and just the idea of film coming down from the Hubble Space Telescope. It's like we have this, it's like we send up astronauts every day to pull down the film and bring it back.
And they wouldn't need Hubble, right? Other agencies have multiple Hubbles sitting in a garage somewhere. They just loan to NASA. You may have heard that, right? So.
Right. The Hubble Space Telescope is the equivalent of the KH-12 spy satellite, but not pointed towards Earth. Okay, and the KH-12 is 30-year-old technology, so the DoD has much better satellites than Hubble.
All right.
Okay.
Of course, there are misconceptions. I like that. And I'm thinking about what you said about parents, you know, and how kids look at that. Andromeda Galaxy, it's not too close, is it?
No, hold on. This is actually true, okay? The current measurement of the motion of the Andromeda Galaxy toward the Milky Way Galaxy is 290,000 miles per hour, okay? So Charles Schultz got that right. But if you do the math, it will not arrive here until 3.85 billion years from now. Okay, so you've got a little bit of ways to look at it.
I like the way you're looking up at it.
You know, Snoopy's gonna, of course, be worried because it's coming at us really fast. All right? You just gotta understand that's 2.5 million light years away.
All right, so we got a list of remedies. We need to confront it. And that's where you come in.
Oh, we didn't tell our favorite story.
We'll get there, we'll get there.
Oh, okay.
In fact, we got two favorite stories.
We got two great stories. Oh, I got three probably.
Explore and test their out their ideas. It's very important. Not just sit there and you tell them, but actually they, what do they call it? Hands-on inquiry learning. Those kinds of things that are really important. That's what makes it possible for them to say, oh, yeah, that makes sense to me. Not always have the right answer. And we'll find that out today as we do our mixed-up solar system activities. They're not necessarily right answers there for you. Concept map. Developing those critical thinking skills.
Okay, so can we do the story now? The next one's your last slide.
It is? Okay. Which story do you want to
Okay,
get?
all right. Can we do the, should I do the Bonnie story? Or?
Yes, the flashlights.
Okay, yeah,
That's classic. All right, we got a great
There are
story.
two classic things that didn't come up today. One, because it's not really a solar system. First question for you all is, why is the sky blue?
Oh, that's
reflects off the ocean.
Because it reflects off the ocean. Okay.
Israelis
Then I
do that
ask
all
you,
the time, all the
sir,
time.
why is the sky still blue in Kansas,
I know.
where there's no ocean
That
nearby?
was my Israeli standard.
Ooh, rally scattering. Okay, you will often find that that's one of the most common misconceptions, okay, why the sky is blue. And of course, the answer truly is because it scatters blue light more efficiently than it scatters red light. All right, why is the sunset red? Because the red light isn't scattered out of the pathway. All right, the blue light is, and you see more red. Also goes through a greater air mass, so notice it more. Okay, second one. Let's do it. Not the flashlight, that's the big fish. The second one, okay? All right, and we've gone across the country, and invariably we find this. Who can answer me? When the cows are lying down, what does that mean? Rain. We get that every place.
Most people do that.
Yes. Of course, there is no correlation between cows lying down and rain. Okay, but everyone knows that if the cows are lying down, it means it's going to rain. Okay, the big fish. All right. You may have you saw Bonnie Eisenhammer when she was here for, and she is what we call vertically challenged. Okay, she's not very tall.
Okay.
All right, and when she was what, 8 years old?
Actually younger, like 4 or so.
4 or 5, all right, we'll call her 5 just for fun. She went out trick-or-treating, okay? And she was of that height that everybody else carrying flashlights, the flashlights were in her eyes all night long, and she hated it, okay? Well, the next morning, she wakes up and she's sick. Turns out she has chickenpox. What did 5-year-old Bonnie conclude? Flashlights caused chickenpox, all right? And she was absolutely convinced of it, all right? And her parents said, well, flashlights, don't bother. No, you're big, okay? Well, here, put it in. No, these were really, really bright flashlights, okay? Her parents used small flashlights. They didn't want to blind her. These were really, really bright flashlights, and they happened many, many times. She would not let go because she had the causation, okay? Flashlights in her eyes one night. Next morning she wakes up with chickenpox. There must be a cause and effect relationship. Okay, so that's why I wanted this. Why would they make it up? Because they experienced it. And it can be very powerful, especially when it's something like chickenpox that keeps you in bed for a couple of weeks. And it's an event. right? And so you deeply feel it. And she said it took her parents several months before she would finally let go of the idea that flashlights cause chickenpox. Okay? So photons are not your friend all the time.
So they persist. Why do they persist? Meditation sometimes, like critical thinking is important. And that second one's important. Especially with the testing. We have to make certain that they're prepared for the test and get the right answer. Sometimes that leads to some unfortunate ramifications. We're going to give you something on the way out. You're going to give us something. You're going to give us the contact card, and you're going to give us a couple of papers. And one thing that you're going to receive is some of the latest research as it relates to misconceptions. I think you'll find this interesting as it relates to the solar system and some other areas of science.